Hello, this is Rahul. In today's lectures, we'll see the link state routing algorithms. As we have discussed algorithms being used by this link state algorithms, we'll see another way how do we actually prepare the list cost tree with the help of link state database. The state of link is called state of link means if it is higher, what it means there are problems in link. If the cost is low, what it means the state of link is quite good. So infinite means the path is broken or disconnected. Router doesn't know. Routers know. Routers know about the other routers which are present in the networks. To how do we actually create this forwarding link state database? What link state database is? Database is collection of link states. Link states means what? Weights on link or the map of networks. For example, I have prepared this database. If I interpret this database, there are number of columns and rows are equal to the number of vertices in the graph, right? Number of routers, sorry, we can say. From A to A, cost is 0, right? From A to B, cost is 2. Initially, A to B, these are connected, so that's why cost is 2. From A to D, cost is 3. A to D, this cost is 3, so that's why I have written here 3. From cost to A to E, infinitive. What it means, they are not directly connected. So A to E, they are not directly connected, so that's why this value is infinite. Similarly, if we verify from G to F, cost is 1. G to F, we see in this graph, G to F, cost is 1, right? Every routers run the Dijkstra algorithm to find the shortest path to other routers. This is the iterative process. So each router sends hello message to the neighbor, as we have seen in distance vector algorithms, and get back the forwarding tables. In flooding, what happens if a router has connected with 4 neighbors, then routers will send its forwarding table to the neighbors. The forwarding tables, the entries will have is IP address, is what? Routers, and sequence number might be there, and it has 2 columns, routers and cost. Means next the devices and corresponding the cost to reach from A to D, cost is 3. If want to go A to B, cost is 2. Roughly I have written this much. This is not correct directly. This is not for this graph only. So create the link state database. With the link state database, you find out the least cost tree. We'll see later, right? So let's create a list cost tree by using the link state database for A. We are going to compute the link state tree for database for router A. What we do, simply for source A, we start from source A. Out of these entry which are not 0, we'll find the minimum one. We'll see, as we have done in Dijkstra algorithms, what it means, we have explored all these vertices. We have 2, 3. These, out of these 2 numbers, 2 is the minimum ones. That's why corresponding to this value, we'll explode all other vertices. So we jump to these columns and see all other vertices, and we'll use the same formula. Suppose we are exploring this one B1, and we see from B to C is infinitive. What it means, A is not directly connected, and A not mean directly, A is not connected with C. Can A reach to C via B? Yes, we see B to C is 5, but A to C is infinitive. We change from A to C via B. that is equal to 7. Similarly, when we explore next one out of we make changes in this vectors, and this goes to 7. In next iterations, what we do out of in this columns, we will find out the next minimum. We have explored this one, we will see next one. This one was not explored, this is not explored, and d was there. So we see dth columns, and corresponding to dth column we explored all other vertices, right? Can we reach all some other vertices from A to C less than the cost? Already it was actually it was infinitive, it was 7. Yes, can we reduce this much cost of, to reach from A to C via D? If you can, then it is okay, no problems, but actually we cannot. Let's check for A to E via D. A to E cost is infinitive. You can see here A to E is infinitive, but D to E is 5. What it means, via D you can reach to the E from A. We can go via D to E, and that is equal to the 5. So the what we make change on table, this is become A. Why it is A to D cost is 3, and then D to E cost is 5. 5 plus 3, 5 plus 3, that would become 8. So that is the reason I have written over it. So this A is explored, B is explored, and D is also explored. We'll see the vertices which are not explored and find out the minimum one. So 7 and 8, out of these two vertices we will find minimum one. C is the minimum. We will see the corresponding to C. So now we see the entries. We will check all the entries, but for the sake of times I am checking only few vertices. Let's check for corresponding to a path from A to F. Can we reach A to F via C? Let's say C to F is 4, but A to F is infinitive. So C to Z is 1, A to Z infinitive. Can we reach all these vertices via C? If you can, then you make changes. This goes to A to F is 11, because 7 is A to C, and 4 is cost from C to F. You can see all these values I am talking about. 7 is what? 7 is A to C, and 4 is C to F, this one, and you get 11 values. You will make change over there, and this is the value. Similarly, we follow the same process again and again. You explore all the other vertices. In this case, you have explored the router E. Corresponding to E, we will find out the what are the changes we can make in this in this column. So what are the advantages of OSPF algorithms, OSPF protocol, because protocols is more than the algorithms. So there are no limits on number of routers we can actually, within the limitation was with protocols. The cost of link is not a number of hop as we had in this distance vector algorithms. In this routing protocols, the cost is actually the bandwidth delay, right? Hierarchy of networks can be built inside a network. This is also possible, and we can assume this as a autonomous organizations, where autonomous organizations having sub-organization as well. No such problem like country infinity problems. Why it is so? Because we are computing the vectors, vector corresponding to any routers by static static vectors correspond to other vectors. What it's static means, there are some rules. First, if a vector A wants to change itself, then A will collect all the routing details of other routers, right? That is the reason we don't have counter infinitive problems. Any problems in the links will not affect the other routers as well. What are the big disadvantages of OSPF is a complexity problems with OSPF is also there. And this is also this is more expensive than RIP, because to implement RIP is very easier, because it has only 15 routers, sorry. So more than 15 is not possible, more than 16 hops is not possible as well. So the I am writing here 15 is the limitation of RIP protocols. 15 devices we can connect with RIP protocols. Thank you.